So this is section 4.4, and we're going to just take a look at an example of a word problem. All of the homework questions in this section are different word problems where you're coming up with a function to model a specific situation. And in most of these you're looking at then finding the maximum or minimum. So let's start with this one. It says David has 400 yards of fencing, and he wishes to enclose a rectangular area. Express the area A of the rectangle as a function of width of the rectangle. For what value of W is the area the largest, and then what is the maximum area? So we're going to come up with an area function. So let's start with, okay, we have fencing. We have 400 yards of fencing, but we want to use that 400 yards to make a rectangle. So we're going to make a rectangular fenced in area, right? So this would be our width and this would be our length. And again, we know that this whole thing, we have 400 yards to work with. So that's telling us really what the perimeter of this rectangle is. So perimeter is 2 lengths, because it would be this plus 2 widths. So 2 length plus 2 width. And again, I know that that perimeter is 400 yards. So 400 is equal to 2L plus 2W. Okay, but we don't want to know, we want to make sure, we want all of this to be within one unknown, right? So since we're looking for making a function of width, how can I describe length in terms of width? Well, if I manipulate this equation, I can get I can solve for L. So I'll know what L is in terms of W. So let's try to get L by itself. So to do that, I'm going to go ahead and I'm going to subtract 2W from both sides to get that W on the other side. So this becomes 400 minus 2W is equal to 2L. And again, I'm trying to get L by itself, so let's divide both sides of the equation by 2. So L is equal to, I'm going to go ahead and do the division and simplify this. So it's 400 divided by 2, which is 200, minus 2W divided by 2, which is W. So L is equal to 200 minus W. So I have my width, and then I have my length in terms of the width, which is 200 minus W. So now if I want to come up with an area function in terms of W, what is the formula for area of a rectangle? That is length times width. So my area function will be in terms of W, and my length is 200 minus W times my width is W. So I came up with an area function. So that is the first question. Express the area of the rectangle as a function of width, or W. So that is this right here. Now if this was all multiplied out, what kind of function would this be? So this would be, let's multiply through that W. 200W minus W times W is W squared. So I have a quadratic function. This is A of W is equal to, I'm just going to write it with that squared terms first. That squared term first. So there is my function. So what do I know? I also know that any point on my graph would be W, A of W. So what does this tell me? W tells me my width, and A of W tells me my area at that specific width. So the next question says, for what value of W is the area the largest? Well, for one, you can graph this function like we did with the box problem lab, or you can know that this is a negative W squared function. So without even graphing this, I know it's going to be a parabola that opens down. And when I'm being asked to maximize something, I'm looking for that highest point, that local max. So in this case, I'm looking for the vertex of the parabola. So the vertex of the parabola will give me the width that yields the largest area, or the maximum area. So once I find that, then I will be able to answer the question, actually the last two questions, for what value of W is the area the largest, so that would be the X coordinate, and what is the maximum area, that would be the Y coordinate. So I need to find the vertex. So remember, the easiest formula for vertex is to look at, okay, we're going to find negative b over 2a for the x coordinate, and then f of that value for the y coordinate. So remember, these numbers come from the quadratic when it's in standard form. So that's ax squared plus bx plus c. So I know that my b in this case is 200, and my a in this case is negative 1. So negative b over 2a is equal to negative 200 over 2 times negative 1, or negative 200 over negative 2, which is a positive 100. So that gives me my x coordinate, or the width of the vertex. So now I need to find f of that number, or since our function is a, I guess it would technically be a of that number, right? So when I plug 100 back into my function, let me scroll this up so we can see our function. There it is. So that would be negative 100 squared plus 200 times 100. So this will be a negative 1, we'd have 4 zeros, right? 1, 2, 3, 4, plus 2, 4 zeros, 1, 2, 3, 4. So it's really 20,000 minus 10,000, which is 10,000. So that is my y coordinate. So again, W, A of W. Since this is the vertex, this is giving me the maximum width and that yields the maximum or largest area, given that 400 yards of fencing that I have. So to answer the question for what value of W is the area the largest, that would be 100 yards. Would be the width. I can't write. Yards. There we go. And 10,000 yards squared would be the maximum area. Okay, so take a look at the other questions that you're asked to do in the MyLabs Plus. You can use the View an Example option that'll give you, a little bit of guidance, but this is kind of an overall, a good example of how you can model a situation to maximize or minimize, by building a function that will model a specific situation.